Okay, we're trying to solve the differential equation that says y prime plus 3 over ty is equal to 5. Note that this diff-EQ has the structure from the book. We have our dy dt. We have a linear y with a coefficient that is in terms of t. And then we have some function on this side. And then they say that m, some other toy function, m is defined as e to the power of this, where recall that p of t is the function that is the coefficient of y. So in this case, p of t is being played by 3 over t. So before we find m, let me just remind us of a couple of things. Remember from your pre-calc days that e to the power of ln of a is simply equal to a. Also remember, a times ln of b is equal to ln of b to the power of a, where the coefficient of a log could become the exponent of the argument. Let's recall these facts. Let's go back up here. First, let's identify our function m. So to find m, you have to identify p. P is 3 over t. So watch, over here, let's find m. So this is e to the power of 3 over t dt. So now focus on this integral. What is the antiderivative of 3 over t dt? Well, the 3 can go out to the front. And then the antiderivative of 1 over t is natural log of t, and then just some constant c. And then, by this fact down here, couldn't I right now bring the 3 to the top? So this is natural log of t cubed plus c. So this here, this is the exponent of e, right? This integral became ln of t cubed plus c. And then we can take this one term and break it up into two. This could go e to the ln t cubed and then times e to the c, because I could go from here back to the previous by adding the powers together. And I want to leave it like this because I want you to see by this fact down here that this first term just becomes t cubed. And then based on the book's recommendation, whenever you have e to a constant, just assign it to equal 1, essentially meaning that our function m is going to equal t cubed. Now, what the heck do we do with t cubed? Once you've identified function m, you take that function and you multiply both sides of your equation by m. So we would have like t cubed y prime plus 3 over ty times t cubed equals 5t cubed. Every term individually received a t cubed. Now, do perform a little simplification where possible. This would be like 3t squared y. And then this is what we have so far. Now you might be wondering, what the heck was the point of finding m and multiplying both sides by m? The purpose of doing that is because on the left-hand side, you'll have something that can be repackaged as a derivative. The derivative of what? The object that goes in here is going to be your function m along with y. So notice that this stayed the same. These are equal because these are equal. Because if I find the derivative of that, if I go product rule, I get this above. Because it'd be like the first times the derivative of that, which is this guy. And then plus the second times the derivative of the first, which is this term. So that's the point of identifying m and multiplying both sides by m, because your two terms on the left could be condensed to the derivative of one term. That's the whole point. Now, at this juncture, we want to take an integral, the antiderivative, because here, this is a derivative and this is like an antiderivative. So in a sense, these eliminate. It's like a positive and a negative, they cancel. So really, we're just left with t cubed y. And on this side, go ahead and give me the antiderivative of that, which would be 5/4 t to the 4 plus some other constant c. And then isolate y by dividing both sides by t cubed. And you get like, what is that, like 5/4 just t plus c over t cubed or something like that. If you divide both sides by t cubed, that's what we should get. And yeah, here we go. So that's one way of doing this problem.